Welcome students for our SLC mathematics video lessons. We are discussing pair of linear equations in two variables. Today we will discuss representation and consistency of lines corresponding to a pair of linear equations. I am Anand, mathematics teacher. This is part 2. Two lines in a plane, only one of the following three possibilities can happen. So let us take in this plane. So in this plane, the two lines are intersecting each other. So the possibility is the two lines will intersect at one point. So this is the point where two lines are intersecting. So this is the first possibility. So the first possibility says that the two lines in the plane intersect each other. The two lines will intersect at one point. This is one possibility. So let us see the second possibility. So the second possibility says that in the plane the two lines lie parallel to each other. So this is the second possibility. So the second possibility says that the two lines in the plane, they lie parallel to each other. So let us consider this plane as xy plane. In this plane, so the two lines will lie parallel to each other. This is one of the possibility. The two lines will not intersect and they are parallel to each other. So then the third possibility is the two lines will be coincident. So coincident means they overlap with each other. So see here, the two lines are overlapping each other. This is the third possibility. So two lines in a plane, only one of the following three possibilities. So the three possibilities are two lines will intersect at one point. So this is the intersecting point. So at this point the two lines are intersecting. The two lines are lie parallel to each other and the two lines will coincident with each other. So these are the three possibilities we see when two lines lie on the plane. Let us discuss the graphical representation and algebraic interpretation of the equations. So see, in the three cases we have three different pair of linear equations. Here a1 is 1 and a2 is also 1. Here a1 is 1 and a2 is 1 and b1. So what is b1? b1 is 1. So b1 is 1 and what is b2? b2 is minus 1. So b2 is minus 1. So what you will get? So 1 by 1 is 1 and 1 by minus 1 is minus 1. But 1 and minus 1 may not be equal. So you can write 1 and minus 1, they are not equal. So if a1 by a2, this one, if a1 by a2 is not equal to b1 by b2, so this is b1 by b2. So here b1 is 1 and b2 is minus 1. So if a1 by a2 is not equal to b1 by b2, then the lines are said to be intersecting lines. So in the plane, the two lines will intersect each other. So these two lines intersecting at a common point. That's why we will get only one point. So exactly one solution. Solution is only one solution. Exactly one solution. System is consistent. Similarly, in the second case, here a1 is 3. Here a1 is 3. a1 is equal to 3. a1 is equal to 3. Then here a2 is 1. Here a2 is 1. Here a2 is equal to 1. So this is 3 by 1. So 3 by 1 is 3. A1 by A2 is 3 divided by 1. And here B1 is 6 by 6, B2 is 2. So which is equal to, so here B1 is 6. B1 is 6. Then what is B2? B2 is 2. So this B2 is 2. So 6 by 2. 6 by 2. That is equal to, what is C1? So C1 is 3900. So 7 is 3900. Divided by, what is C2? C2 is 1300. It is 1300. It is 1300. So here we will get 6 ones are 6, 2 ones are 2, 3 is 6, this is 3. Here you cancel these two zeros and you cancel these two zeros. 13 ones are 13, 13 3 is 39. So here we will get A1 by A2 is 3, B1 by B2 is 3, and C1 by C2 is also 3. Therefore, the lines are said to be coincident lines. So coincident line means in the plane, the two lines will overlap each other. The two lines will coincident with each other. Infinitely many solutions. So many solutions means so many points are there. So many points lie on this coincident line. So many points and many solutions. So this is dependent. System is dependent. In the third case, go to the third case. Here A1 by A2 is 2 by 4. So A1 is, so here A1 is 2. So A1 is 2 divided by A2 is 4. So A2 is 4. A2 is 4. Then that is equal to, what is B1? B1 is minus 2. B1 is minus 2 divided by B2 is minus 4. B2 is minus 4. That is equal to, what is C1? C1 is minus 2. C1 is minus 2 divided by C2 is minus 5. C2 is minus 5. Now, if you see, A1 by A2 is 2 by 4. Here B1 by B2, B1 is 2, this is 2 and 4. So 2 by 4, ratio is same. But C1 by C2, this is minus 2 and minus 5. So this is different. So this is different. So if A1 by A2 is equal to B1 by B2, but not equal to C1 by B2, then the lines are said to be parallel lines. So parallel lines means in the plane, they lie, two lines lie in equal distance. In this type of graphical representation, no solutions and the system is said to be inconsistent. This is how we can represent the consistency of lines corresponding to a pair of linear equations. So by solving these two equations in graph, we can see how these two lines will lie in the same plane. So this type for the first type they are intersecting. For the second type, they lie one on the other and they coincident with each other. In the third case, the two lines are said to be parallel to each other. This is how we can interpret by knowing the equation. We can interpret the graphical representation of the given equation.